This will be for the Chapter 4 practice test, combinations of functions. All right, problems 1 through 5 refer to f of x equals 1 over x minus 3, g of x equals 2x plus 4. Number 1, they want us to find the domain for f plus g of x. And we have the multiple choices. Now, do we actually have to find f plus g of x? No, we just need to find the domain of each function and then take the overlap for the domains. All right, so let's look at the domain for each one for the f of x function. The only restriction here is that the denominator cannot be 0. Okay, so if we do x minus 3 equals 0 and add 3 to both sides, that's going to be x equals 3. All right, but we said the denominator cannot equal 0, so basically x cannot equal 3. All right, and then on the g of x function, there is no value of x that wouldn't work. Okay, so g of x is all real numbers. As far as the domain, you're allowed to plug in anything in place of x. So the overlap between the two, this is all real numbers. This is x not equal to 3. All right, so this is the only restriction right here, x not equal to 3. So the domain runs from negative infinity to positive 3, and you use the rounded parenthesis because it doesn't include 3, in union with 3 to positive infinity. All right, so this right here says it goes all the way from negative infinity, but it doesn't include 3. See, the rounded parenthesis on the 3 means it's not included. You always use the rounded parenthesis on the infinity. All right, so this is how you write everything, all real numbers except for 3. All right, so that is answer B right there. All right, number 2, they want us to find f of g of x. Remember this little circle, think of the word of. So this can be written as f of g of x. All right, and what that means is plug in. We're going to plug in g of x in place of x. Okay, so think about it. If you have a function f of x, let me erase this here. If you have a function f of x, whatever you put in the parentheses, that gets plugged in place of x. So that g of x function gets plugged in place of x into the f function. All right, let's see. F of g of x all right, here's the f of x function, and here's the x right here. We have to take g of x and plug it in place of x. All right, so it's going to be 1 over x minus 3, which means 1 over, instead of the x, we write 2x plus 4. And that is minus 3. Okay, so it's basically 2x plus 4 minus 3. All right, so this was your x in the f function, and we just plugged it in. That's going to be 1 over 2x. Combining like terms, 4 minus 3 is positive 1. That's it. And that is answer A. 1 over 2x plus 1. All right, number 3. Find g of f of x. All right, so this is written as g of f of x. All right, so basically, you start with g of x, and you plug in the f of x in place of x. All right, this is g of f of x. So let's look at the g function now. All right, we're going to take f of x, which is this here, and plug it in place of x in the g function. All right, so it's going to be 2 times 1 over x minus 3 plus 4. All right, that's going to equal 2 times 1 over x minus 3 plus 4. All right, use parentheses. 1 over x minus 3 plus 4. All right, this was x right here. This thing right here was x. And I just plugged in this whole thing. So use parentheses. And pretty simple from there. 2 times 1 is just 2. That's divided by x minus 3. And we still have plus 4. And that is answer C. Number 4, find f of g of 4. So that is written as f of g of 4. So what does that mean, f of g of 4? That means in the function f of x, we're going to evaluate g of 4 and plug that in wherever we see an x for the f function. All right, so let's see what that equals. G of 4. You just have to go to the g function and plug in x equals 4. All right, so if you go to the g function, that's 2x plus 4. All right, so if we do 2x plus 4 at g of 4, you're just plugging in 4 in place of x. All right, so that's going to be 2 times 4 plus 4. 2 times 4 is 8, plus 4 is 12. So f of g of 4, we said g of 4 is 12. So that's going to be f of 12. All right, now we have to go to the f function and plug in 12. So the f function is 1 over x minus 3. And we're just plugging in 12 in place of x. So it's going to be 1 over 12 minus 3, which is 1/9. Final answer. So number 4, that is answer B. All right, number 5, find the inverse of f of x. All right, this is the inverse function. This is not an exponent. It's not f to the negative 1. That means inverse. All right, what you do for the inverse, you interchange x and y, and then solve for y. All right. right, so let's look at the function f of x. From this right here, we have f of x equals 1 over x minus 3. F of x, that's the same as y equals. All right, so it's going to be y equals 1 over x minus 3. All right, so that's the original. Now we're going to interchange the x and y. The y becomes an x, and that equals 1. The x becomes a y. And now we're in business. We need to solve for y. All right, I am going to, let's say this is x over 1. I'm going to take the reciprocal of both sides. There's more than one way to do this, but I'm allowed to take the reciprocal of both sides. So x over 1, that's going to become 1 over x, and that equals y minus 3 over 1, but that's just y minus 3. All right, I can put it over 1, but that's the same thing. Solving for y, just do plus 3 on both sides. Cancels here, and this is going to be 1 over x plus 3. That equals your y. So that's it. Now, instead of y, it might say, I'm not sure of the choices here, but it might say f of x equals 1 over x plus 3. Or it might say the inverse of f of x is 1 over x plus 3. Or whatever it is, it's going to be 1 over x plus 3. All right, it looks like from the author's answers, there is a common denominator here. So we need a common denominator. I am going to multiply. Here's a denominator of x. So I'm going to multiply the 3 by x over x. Okay, this is the same as times 1, so it doesn't change anything. All right, so we have 1 over x plus 3 times x is 3x, and the denominator is x. All right, and now we have a common denominator of x. See that common denominator, and 1 plus 3x is the numerator. And that is answer B. 3x plus 1 or 1 plus, whoops, nope. Wrong again. That is answer C. 1 plus 3x, 3x plus 1, and x is in the denominator, so that's good. Number 6, the graph of f of x is given. Does f of x have an inverse? All right, the way to test for an inverse is for the horizontal line. All right, a vertical line tests if it's a function, but the horizontal line tests if it has an inverse. And if it intersects at any point more than once, then it's no. All right, so we have to use the horizontal line test. Now, this one is actually a trick or a tricky question. Okay, it's kind of ridiculous. I don't like this example, but you can see right here, it intersects once. Right here, it intersects once. If you go right here, it looks like it intersects more than once. All right, but the reality is, if this graph was more accurate and you could zoom in, really the only point where it intersects is right there in the middle. So it actually intersects just once right there, although it's very hard to see. All right, so this one is a trick question. But even right there, it only intersects once. I won't give you anything tricky like that on the midterm. All right, but the author's answer is yes. All right, and that's because it only intersects once right there. If the curve, if it was something like that, and you drew the horizontal line, then yeah, it's obvious it intersects more than once. All right, and the answer would be no in this case. But that's not what we have. All right, so it's actually a yes. All right, number 7. Are f of x and g of x inverses? In order for them to be inverses, you have to evaluate f of g of x, and you also have to evaluate g of f of x. And in both cases, you have to get x. All right, so it has to be both of those. So let's try f of g of x first. All right, f of g of x means we're plugging in g of x in place of x for the f function. So if I took this right here and plug it in place of x, let's see what we get here. All right, we're going to do 2 of these now. So it's going to be 1/2 times x. So that's 1/2 times 2x minus 3. And that's going to be plus 3. All right, 1/2 times 2x, the 2's cancel, and we're left with x. And 1/2 times negative 3 is negative 3/2. And then we have plus 3. All right, I can see already that's not going to equal x. Negative 3/2 plus 3 is going to be positive 3/2, which does not equal x. So the answer is definitely a no. All right, you don't even have to do the other one. I'll do it just so you can see it for practice. All right, g of f of x means we're going to take f of x and plug it into x for the g function. So if we took this here and plugged it in place of x, we would basically have 2 times x, or 2 times 1/2 x plus 3. All right, whenever you plug in a function in place of x, use parentheses where that x would have been. It's cleaner. All right, and then you have a minus 3. 2 times 1/2 x, 2 times 1/2 cancels, and then 2 times 3 is positive 6, minus 3, and that's going to be x plus 3, okay, which does not equal x. All right, so again, in order for it to be yes, both of these have to equal x. All right, if either one doesn't equal x, you're done, and the answer is no. So this step was unnecessary. All right, what is the domain for f of g of x? The functions are right here. So f of g of x, all right, I'm just going to rewrite f of g of x. And in order to find the domain, you have to find the domain of the overlap between the composite, which is f of g of x, and the inner function. I'll just put fn, inner function. All right, I'm sorry if that's hard to read. The inner function is the one right here in parentheses. That's g of x. All right, so we have to find f of g of x and its domain, and we have to find we have g of x and its domain, and then we're going to take the overlap between the two. All right, so let's calculate f of g of x. I'll do that in a different color. F of g of x means we're plugging in g of x in place of x for the f function. We're going to take g of x, which is this right here, and plug it in place of x. So that's going to be 1 divided by x minus 2 over x plus 2. All right, and using keep, change, flip, keep 1, change division to multiplication, and flip this right here. So it's going to be 1 times x plus 2 over x minus 2. And of course, 1 times anything is just going to be that thing. So x plus 2 over x minus 2. All right, so what's the domain here for this right here? Well, the denominator can't be 0. So the domain for f of g of x cannot equal 2. All right, I'm not going to write it with the parentheses and the infinities yet because I don't have to. The domain for f of g of x cannot equal 2. All right, and now let's do the inner function, which is g of x right here. All right, the domain for g of x, what is g of x? X minus 2 over x plus 2. So the only thing it can't be, the denominator can't be 0. So x cannot be negative 2 because you would get negative 2 plus 2 and you would get 0. So for g of x cannot equal negative 2. All right, so it's both of those. All right, remember we're looking for the overlap. So just so you can see it, I'll do it on a number line. All right, let's plot 2 and negative 2 on the number line. And in the one case, it's going to be everything except 2, right? So you have a little circle at 2, and it's going to be everything else. Everything else except 2. And then for the other one, it's going to be everything except negative 2. All right, and let me see. That would be it right there. Okay, you have to exclude negative 2 and 2. You have to exclude both of them. So this side is negative infinity, and this side is positive infinity. All right, so to write that out, you start at negative infinity, and you go to negative 2, and it doesn't include it, in union with negative 2 to positive 2, and again, it doesn't include it, so you use the rounded parenthesis, and then it goes from 2 to infinity. All right, always use the rounded parenthesis for infinity. If the number was included, you would use the squared off bracket like that. But this is the final answer. All right, and that is this one right here, answer B. All right, the solid graph is the graph of f of x. The dash graph is g of x. So let's label those. All right, so the solid graph is f of x. And the dash graph here is g of x. All right, we want f of g of 4. All right, so that's going to be f of g of 4. All right, that's how you would write it. So let's find g of 4 first. All right, g of 4, if we go to the graph, here's the g graph, right? And this is x equals 4. So go to x equals 4, And here's the G graph. Trace that to the G graph. And then you find the y coordinate. And that is at 2. All right, so G of 4 is going to be 2. And then we have to find F of 2. All right, again, this is x equals 2. So go to the x-axis, x equals 2. And the F graph is the solid one, this one here, the solid line. So we want to trace that to the F graph and find the y coordinate. That's -3. So that is the final answer. And it looks like that is answer B.